All right, so according to your votes, these questions of motion are what you struggle with the most. And so there's really two types, the kinematic motion and also what I call the differential and integral motion questions. You have from the most recent past papers these questions on this worksheet, and I've gone ahead and answered them all in detail for you. And so that will be in the description. You can download that and go through it to get a better understanding of how to answer this question, how to get it correct in your exam. In terms of the formula sheet, you have these formulas, and that's all they really give you. And by the way, this further mechanics, further statistics, and further pure mathematics will all be covered and done very soon on my Patreon. But yeah, in this video, really, we're just going to go through two different questions. We're going to go through a kinematic question and a differential and integral motion question. So let's do that. And these two, I selected them. They're what I see as the hardest ones out of the questions on the worksheet. Okay, a train is travels 4.8 kilometers between two stations A and B. The train starts from rest at A and accelerates at a constant rate until it reaches a speed of 30 meters per second. It then travels at a constant speed for t seconds before deaccelerating at a constant rate and coming to rest at B. The total time for the journey is 180 seconds. Find the value of t and hence find the value of t and hence find the distance moved by the train while moving at a constant speed. Well, can do. Okay, so with these questions, first of all, you're gonna just write down what they give you. I went through this in the examinations video I did, like where I talk. So write down what they give you. So first of all, they give you the distance between A and B. This is 4,800 meters. And also they give you the total time, I guess to call it T total is going to equal to 180 seconds. What else do they give you? They give us, well, there's kind of three segments here. You got the train starts at rest. So we got the first segment, so segment 1. The train starts at rest, so our initial velocity is 0 meters per second. And it accelerates at a constant rate till it reaches a speed of 30 meters per second. So its final is 30 meters per second. Acceleration, we don't know. And this distance or displacement, we also don't know. So we don't know those two things. What about the next segment? So straight away, before I even begin answering, I'm writing down everything they've given me. It then travels at a constant speed. We could call this 1. So for the first segment, we also don't know the time. We call it T1. We also don't know how long that is. For the second segment, it then travels at a constant speed of t seconds. Okay, so its initial for this segment is going to be 30 meters per second. Its final for this segment is going to be 30 meters per second. And its acceleration for this segment is 0 meters per second squared because it's not accelerating, it's moving at constant speed. The distance, we don't know. Again, we don't know what this is. And the time taken is t. And the final segment 3, well, it then deaccelerates. So then you've got its initial is 30 meters per second. It deaccelerates concentrated becoming to rest at B. So then its final B is 0 meters per second. And that's all they give you. So we don't know what the deacceleration is. We don't know how far it travels. And we also don't know the time. But we do know that, our distance AB, well, this is just going to be the displacement of 1 plus the displacement of 2 plus the displacement of 3, or the distance, or however you want to think about it. All right? So all of those things And that thing equals to 4,800 meters. Just 4,800. And the total time, this total, T total. T total. Well, this is going to be T1 plus T2, which is T, plus T3, and this thing equals to 180 seconds. All right, so with that in mind, you then probably are going to get to this point, okay, well, what do I do? Well, so you should go to your formula sheet, and so you really, like, I'm trying to think of how to explain. So you're looking at this, okay, you've got something in terms of a distance. You've got a number for a distance. You've got these velocities as well for each segment, but you've got a number in terms of the distance and a number in terms of the total time as well. So, I mean, one of the equations, so distance and time is clearly going to be something important. So you have this equation on your worksheet, right? And so what I would do, opposed to this, well, let's start to figure out what these things are. Just even if they're not in terms of numbers, you just figure out what they are, and you can get an equation for them. So for this, for example, so for S1, the first one would be a half of U1 plus V1 times T1. Right, you can see that by using this equation here, it's probably going to be useful because we're trying to find T, and if we find T, what does it want at the end? It wants the distance traveled, so which will be very easy if we find T. So for this one, it's just going to be a half of U1 is 0 plus V1 is 30 times T1. So this equals a half of this 15 T1. All right, so that might be important. S2, this is a half of U2 plus V2 T2, sorry, which will be a half, well, U2 is 30 plus 30 is V2 times T2 is just T. So this is just a half of 60, which is 30T. And then the final one, S3 is a half U3 plus V3 times T3. This equals to a half of U3 is 30 plus V3 is 0, T3. This is going to be 15 T3. Right, so with that, so let's say, okay, so you found that. And now you say, well, okay, I have an equation up here which can relate these things together in terms of T. And so maybe that'll be useful. And so again, with the thing that I said in my video, you want to uncover more information with the information they've given you. That's information from the formula sheet. This is the information they've given you. This is the information they've given you. And from this information here, you've found how to express this distance in terms of time. And so our total distance, DAB, which will be 15 T1, right? Our S1 plus our S2 is 30T plus 15 T3. Right, and that whole thing equals to 4,800. So we have now 15 T1 plus 15 T3 plus 30T equals to 4,800. Right, but we also know that this total time is 180 seconds. Right? So we can write this thing. We can say that the total time, so T total equals to T1 plus T plus T3 equals to, this is going to be important, equals to 180. So we can get the T equals to 100, or you could say T1 plus T3 equals to 180 minus T, right? And now you can see that if you factor out, so look, at this point, all we've done is just find more information from the information they've given us. From this key thing here, which they've told us. Because other than that, they really haven't told us that much. They haven't given us any of this crap. And so if you take, let's call this equation 1, equation 2. If you take equation 1, and you factor out a 15, you get T1 plus T3 plus 30T equals 4,800. Right? And we have that here. And the reason that you want to substitute this thing into here is because then you have an equation with only T, and then you can find T. So this thing will be 15 of 180 minus T plus 30T equals 4,800. Right, and then you figure this out. 15 times 180 is 2,700 minus 15T plus 30T equals 4,800. So you get, therefore you get 15T equals to 4,800 minus this is 2,100. So therefore you get T equals to this divided by 15, which is 140. So that's your answer. What else does it want? And hence find the distance moved by the train while traveling at a constant speed. Well, that's very easy now, because you have this train, it's moving at a speed, it's moving at a speed of 30 meters per second. Right? Yep. It's traveling at, its time is 140 seconds. And so therefore, because velocity equals distance over time, therefore distance will just equal VT. So the distance for this second segment is just going to be 30 times that. So it's 4,200 meters. All right, and that's your answers. Well, see, where I believe that people would get stuck is first, like, you have to realize, okay, they've given you this, and so distance or displacement and time are the two real potent equations that you're going to need to use. Therefore, you go to your formula sheet and you find an equation relating those two things, noting they also give you these two things in all of these situations. And then you use that to basically figure out, how can I get an equation just with T? And by doing that, you can find your answer. Okay, and now this next one is differential. This usually comes at the end of the paper because it's probably one of the hardest, if not the hardest, and it's worth a lot of marks, like 6 and 7. So that's 13 marks. That's quite a lot compared to your paper. That's like almost a grade and a half. But with this stuff isn't actually too difficult. So again, we write down what they give us. A particle X moves along a straight track starting from point O at t equals 0, and the displacement of X from O at t seconds is s meters, where s equals, so the relationship between displacement and time is this. So this is our A. So s equals 3t to the power of 3 over 2 minus 6t. Okay, find the time at which X is instantaneously at rest, and hence find the total distance traveled by X between t equals 0 and t equals 16. Well, X is at instantaneous rest. When does this happen? This happens when ds by dt equals 0. Right? It's not moving. It's not changing its velocity. Right? And this is just velocity, ds by dt. So therefore, if you find, because it's kind of giving you a hint, right? It's saying find at which X is instantaneous at rest, and then find the total distance between these two t values. So let's do exactly what they tell us. So ds by dt, again, you can see we're uncovering more information by doing this. This is d by dt of s, which is 3t, 3 over 2 minus 6t. All right, and that just will be, well, this will be, you can expand it in if you want to be really pedantic, but I won't. So this is just 3, and then we got t, you times down by the power, so times by 3 over 2. I guess I will explain it, so it'll be very clear. So this is saying this. Right, and this thing here is 3 times, well, this thing, 3 times 3 over 2 times down by the power, go down a power, so it'll be t to the half minus, well, this is just 6. All right. So this would be 9 over 2 t to the half minus 6. So ds by dt equals this. So that means our velocity, because this is also our velocity, equals this. I mean, you could even rewrite that if you want to be very clear to yourself. Right, so that's clearly going to be important. Right, and so this thing is at instantaneous rest when its velocity is 0. So therefore, for the instantaneous rest, the time when it's at instantaneous rest is at 9 over 2 t to the half minus 6 equals 0. Right, and now you get t to the half equals to 6, so 9 over 2. So times 6 times 2 divided by 9. This gives you what? This gives us 12 over 9. Therefore, t equals, we just square both sides to get rid of the t. And so it would be this squared, which in a fraction is 16 over 9. So this value here, this means that at instantaneous rest, this occurs when t equals 16 over 9. And then, so now that we have that, it wants us to find the total distance traveled by x between 0 and 16. Okay, so for this part, so this total distance is going to be like, it's going to be the sum. So you have like, because when it goes to instantaneous rest, like you've got this displacement equation here, So you're going to want to find basically the absolute value of the displacement, we call it S1, between t equals 0 to t equals this instantaneous rest point. Right? Because it could, when it goes to instantaneous rest, it could be turning around. And in that case, if you just sum up these, if you were just to calculate this value here between 0 and 16 without looking at the first part where before it comes to instantaneous rest and after it comes to instantaneous rest, if you just do that, well then you're not going to get the actual total distance, because it could go like this, comes to instantaneous rest here and then come back here. And therefore its displacement from this initial point is only this distance, and you'd get that value. And then you wouldn't know what the total distance is. So in splitting it up, you find, first of all, you're finding, because you don't know if it turns around, you're finding this point here, we're calling that S1, up to from t equals 0 to t equals 16 over 9, right? And then we're finding this next distance, yeah, which we'll call S2, which will be from t equals 16 over 9 to t equals 16. Right? I mean, maybe the absolute value is a bit overkill, but you will be taking the absolute value of this stuff, because this thing here, this distance here will be positive and this distance here will be negative, but the summing them both up will give you the total distance. So this plus S2 between t equals 16 over 9 and t equals 16. Right, and that's actually quite easy to do. So you have the equation, this equation at the top. S equals 3t 3 over 2 minus 60. So 3t 3 over 2 minus 60. So for this first one, this S1 between t equals 0 and t equals 16 over 9. Well, this is just going to be, well, it's just going to be the at 16 over 9. So this thing at 16 over 9 minus what it is at t equals 0, which will be 0, but I mean, you can plug it in if you want to be super clear. So this will be 3 times 16 over 9 to the 3 over 2 minus 6 of 16 over 9. That thing minus 3 times 0, 3 over 2 minus 6 times 0. Right, and that's clearly going to be 0. So you just need to find what that thing is. So 16 over 9 to the power of 3 over 2 times 3 minus 6 times 16 over 9. So this gives you a value of minus 32 over 9. So this is minus 32 over 9. Right? So its distance is 32 over 9. But its displacement is this, which clearly means that it's traveling this way, and then it comes to instantaneous rest and starts traveling this way. Well, I guess if the other one's positive as well. And S2 for t equals 16 over 9 to t equals 16, you just do the exact same thing. But in this case, now you're finding from 3 of 16, 3 over 2. I'm just plug it into this thing. 3 over 2 minus 6 of 16, that thing, minus, right? Because you're calculating the distance, this distance here between these two values. So you have to minus the distance basically between 0 and 16 over 9, which is exactly what you're doing here. So minus 3, it's just going to be this value. But I guess I can plug it in. 3 over 2 minus 6 of 16. Right, so what is that? 16 to the power of 3 over 2. 64 times 3 minus 6 times 16. So it's 96 minus, well, we've already found that above, it's this. So this thing is minus 32 over 9. So this is 96 plus 32 over 9. So this is 896 over 9 meters. All right, so this is your S1, that first distance. This is your S2, that second distance. So the total distance, this total distance is just going to be 32 over 9 plus 896 over 9. So 896 over 9 plus 32 over 9. Not minus, because you're finding distance. You're only interested in the value, not the direction. Which equals to what? Plus 32 over 9. So this equals to 928 over meters. So your distance is 928 over 9 meters. Right, and that's the total distance traveled by x between t equals 0 and t equals 16. Right, the hard part of that is understanding that instantaneous rest is a point in which has to be heavily considered in your calculation. B. A second particle y moves along another straight track, starting from point P at t equals 0. The acceleration of y at t, this is A is this. When y leaves P, it's 7.5 meters per second. All right, so let's write down what they give us. So we've got another particle. So there's another particle. A, its acceleration is 0.8 minus 0.6 t. So its acceleration is 0.8 minus 0.6 t. And the velocity of y when it leaves P is 7.5 meters per second. So the velocity at P is 7.5 meters per second. All right, now what does it want? What do you want? When the velocity of y is negative 9.6 meters per second, show that displacement of x from O is equal to the displacement of y from P. Okay, so basically what we're going to need to do here is at this point, when our velocity of this particle y is minus 9.6 meters per second, we want to know at what time does that occur? When does that occur? If we have what time that it occurs, then we can find the displacement of this y particle at that time. And then we can also find the displacement of the x particle, so t of y. We also know that what will be the displacement of the x particle as well at that time. And if we do that right, then those two displacements will equal each other. So the first step is to find an equation for the velocity. That's what we first need to do. So we need to find a relationship for the velocity of y. Okay, we have the acceleration. Acceleration is the rate of change in velocity. It's this. So therefore we get dv equals 0.8 minus 0.6 t dt. We integrate both sides. Therefore we get v equals to, well, this is just 0.8 t minus 0.6 t squared over 2 plus some constant, which we don't know. Okay, let's simplify that a bit more. So v equals to 0.8 t minus 0.3 t squared plus c. Now, in terms of this c, we know when t equals 0, we know they've given us this at t equals 0. So when it leaves p, our velocity is 7.5 meters per second. So to find this c, so as when t equals 0, our velocity is 7.5 meters per second, right? They give us that, they tell us that, right? Because it leaves p at t equals 0, and also it leaves at a velocity of 7.5 meters per second. So with that kind of data point, we can then find, so therefore we say 7.5, substituting it into this thing, 7.5 equals to 0.80 minus 0.30 squared plus c. So therefore, this is just going to be 0. So therefore, we get c equals 7.5. So overall, we have this velocity equation. Velocity for this y particle is 0.8 t minus 0.3 t squared plus 7.5. Right? And that's probably going to be important. Right, so now that we have that, we want to know, okay, because like I said at the start, we want to know, okay, at what time is its velocity this? And to do that, we just say, okay, so we want to know, so we want to find at what t is its velocity equal to minus 9.6. You can see we're just uncovering more and more information. Right, with that in mind, that we're going to have to find some sort of displacements here. Minus 9.6 equals to 0.8 t minus 0.3 t squared plus 7.5. So therefore, if we take all this stuff over, we get 0.3 t squared minus 0.8 t, and then minus 9.6 minus 7.5 gives us minus 17.1 equals 0. Just use the quadratic formula to figure this out. So t equals minus b, which would be 0.8, plus or minus the square root of b squared is minus 0.8 squared minus 4, 0.3 a. I'm just using this equation. You probably should know this. To a, where this thing is just x. I guess ax squared plus bx plus c. Anyway. Times minus 17.1 divided by 2 times 0.3. Right, and then, so you get 0.8 squared minus with plus 4 times 0.3 times 17.1. that thing's square rooted is 4.6. So therefore we get t equals to 0.8 plus or minus 4.6 divided by 2 times 0.3 is 0.6. Right, and clearly it cannot be this negative one because we can't have a negative time. Although I might talk about that at the end of the video, but we can't have a negative time in classical physics. So therefore our t equals to 0.8 plus 4.6 over 0.6, and that just equals to 0.8 plus 4.6 divided by 0.6. Oh, 0.8 plus 4.6 divided by 0.6. So this gives us 9. So that means that at v equals minus 9.6 meters per second, this happens at the time of 9 seconds, right? And now all we really need to do is figure out the displacements. So the displacement, we have the displacement equation of x for this x particle was 3t 3/2 minus 6t. So we could call it 3t 3/2 minus 6t for x, and for y, well, we don't actually know what this is. Right, but what we do know is that ds, or velocity by dt, from here is 0.8t is equal to 0.8t minus 0.3t squared, 0.3t squared, plus 7.5. So let's find what this is. So ds equals to 0.8t minus 0.3t squared plus 7.5 dt. Right, just times by dt, and then you integrate both sides, and you get therefore this s of y will equal to, or you just figure out this. So it's 0.8t over 2 minus 0.3t cubed over 3 plus 7.5t plus some new constant k, which we don't know. So therefore, if we simplify it further, we get 0.4t squared minus, this will be 0.1t cubed plus 7.5t plus k. And now to find k, well, we know that like when t equals 0 for this y particle, like you just need a point. So you can see a second particle, so at t equals 0, the accelerator, So, but it starts at t equals 0. So at t equals 0, its displacement is 0. Right? It doesn't tell us anything about, like, it starts at that point. So when t equals 0, unless it explains otherwise, I mean, when t equals 0, s equals 0. Right? And we're finding this point because we have an s and t equation. So therefore, I mean, a will just equal 0. I mean, you can plug it in if you want. I mean, 0 and, 0.4, 0 squared minus 0.1, 0 cubed plus 7.5, 0 plus k. All right, this entire thing is 0, so therefore you get k equals 0. So therefore, for s of y, you get 0.4 t squared minus 0.1 t cubed plus 7.5 t plus 0. So that's your y for y, and that's your f for x. So now all you need to do is you want to show that the displacement of x is the same as the displacement of y when t equals 9. Because at t equals 9 is when that velocity is minus 9.6, which we found. So now it's actually quite easy. So it's not the end quite yet. Never give myself enough space. It's a real problem. So, therefore s of x, this is at t equals 9. Well, that's just going to be 3 to the 9 of 3 over 2 minus 6 to the 6 times 9. What does that equal? 9 to the power of 3 over 2 times 3 minus 6 times 9. So that's 27 meters. So hopefully this will also equal 27 meters. If not, then we've done it wrong. So this will be 0.49 squared minus 0.19 cubed plus 7.5 times 9. That will equal to 0.1 times 9 squared. This is 32.4 minus 0.1 times 9 cubed, 72.9, plus 7.5 times 9, 67.5. And hopefully that sums up to 27. So 32.4 minus 72.9 plus 67.5. And it does. So therefore we've shown that s of x equals s of y, which equals 27, at the velocity of y equals minus, what was it, 9.6 meters per second. 9.6, right? Yes. Okay, and that's it. I mean, that's really as hard as it gets, that question in terms of differential. I think this is the one that people struggle. It's just integration and differentiation. Again, I'll hammer this home so many times. It's like, uncover more information. If you don't know what to do, uncover more information. If they give you the velocity, well, then find this displacement, through ds, through v equals ds over dt. You can also find the acceleration, because acceleration is dv by dt. You can find more information with all these questions. Anywho. All right, and that's it. So download the worksheet and go through it. It should be a lot easier. And now I might just have a yarn about really motion in general, and the two biggest ideas, and the biggest ideas probably that we have is time and space. And so I'll talk about that now. This is going to probably become a common occurrence, as I'm going to be sitting out here and we're just going to talk deeper about anything in the future. I mean, I am developing and theories and even ways of perceiving the world, which I believe can be collectively very important. But right now, again, I just want to be introducing and making people become aware of things that I feel need to be talked about and heard. And I'll probably be lighting up a cigarette a lot. But let's talk about mechanics, an overview of mechanics. And in particular, because this video we tackle questions on motion, really, what are the two key ideas that are found within motion and describing motion? It's these: space and time. Now, obviously, this could be talked about and has been talked about in general for possibly thousands of years. But we're just going to be having a more relaxed yarn about it. It's not a relaxing subject, but I just want you to become aware. Just removing all of the information that has been given to you by books, by other people. I just want you to just remove that and just notice that you don't actually know what time is and what space is. You don't know. And really, a discussion can only be heard. This stuff that I say can really only be heard is if you first come to that place that you don't actually know what those things are. You have conceptions of what they are, but you don't actually know what they are. What is time and what is space? Are they illusions? Are they real? For example, with space in particular on a societal level, having the conception of space means that you move towards a future place, physically. So having that as an idea ingrained into our population means that they know how to move. And that, you see, we can't even imagine that that's an idea. If you didn't have that idea, it may be inconceivable to you that you could even go down over to that place. That might be an impossible thing to you. Because this idea is so like true to us, we just take that for granted. But space in general, I mean, I've done a lot of study of Einstein and his work, and I won't go into it now. But space in general is not something linear. It's not something like known very well. I mean, even 100 years, like in the last 100 years, this idea of space has been completely recontextualized. And it's actually, according to Einstein, there's some sort of warping of space due to other forces or phenomenons in physics, and even warping of time. These things are actually warped, and they're not like mechanical. It's not like a ticking clock. Even time, and this again, I'm just going on random yarns here. There's no real structure to this. I just want to talk about this. In the future, I will structure these and talk deeply about them. But if you think about time, like just the clock, it seems to me that time and the way that we perceive time or understand time has some sort of deep connection to oscillation. Even like a year is some orbit of the Earth around the sun. A month is an orbit of the moon around the Earth. Or even just a clock, as in like, think about an old clock, you have that oscillating thing which is ticking. So there's a deep connection between the physical world which we're perceiving and our conception of time. Because when you think about time, you might just think, oh, well, this is just like, what is it anyway? I mean, like, how can I even think about it? But if you think about it through the perspective of, it is the time that you experience and how you feel, like that time is based heavily on physical phenomena. Like the time that we present ourselves in society is based on physical observations. But time itself and this is where my intuition kind of leads me, it is a complete illusion. The fact that we even believe that a certain amount of time has gone by is completely ridiculous. I mean, it's also, time is seemingly heavily experienced differently based on how much change is happening to you internally. You'll hear it all the time. People say, like, I don't know where the last 20 years go. And that's basically because they've done the same thing and they've been trapped in a routine for so long that time just flies because nothing changes. Where if I was to grab you and put you into a chaotic situation, the time that you experience would be extremely stretched. It would feel like years when objectively, how society judges it, it might only be a week. And this is what I mean. I mean, these things are not some sort of obvious and objective thing. Time is experienced different by different people. Space is experienced different by different people. Like spatially, like if you think about it physically, it's one thing. But what about if you think about the space as an idea? Like space, how much space you have maybe within you, or how much space you have like thinking, and like you can expand yourself physically, like not physically, I mean, it gets very niggly with this stuff, because what is physical? What are these things? I just want people that listen to me to become aware that this is very, very, very strange, extremely strange. In fact, it's so strange that if you were to really experience how strange reality is, it would obliterate what you are. See, the self, it seems, the self and what you identify as is stable. And it's stable, and therefore the world can be understood. But if it is seen, really seen, if you really see the world or reality for what it actually is, this thing, this individual that you are, just ceases to exist. There is no Jacob anymore if reality is fully experienced. And the individual as a thing is heavily tied down to a space and a time. You think about it, you actually feel like you're here in a particular place. That feeling of being here is based upon
an idea, a deeply rooted idea, which is controlling your psychology and your psyche. And you feel like you're here. And that's almost it's undeniable to you. If someone was to ask you and come up to you, are you here? You would say, yeah, I'm here. That feeling of being here has a massive spatial component, which isn't just confined to the physical. This spatial recognition of being here and noticing things that are far away. This is something that's very profound, and it's an idea that has influenced our entire world completely. But it is, and this again is an intuition of mine, it is an illusion. What do I mean by an illusion? Illusion means that it isn't real. What do I mean by real? That's the thing. Like, when something becomes real, it's almost undeniable. You cannot see. It's very easy to do with many ideas. Like, you can perceive it through different kind of ways, and by doing that, you actually change its reality. But with something that's real, it really ties down to the idea of realization. When you realize something, then it becomes actual. It becomes here. It becomes real. And that idea of real, in terms of space and time, is a collective real which has been realized. But in reality, I do not intuit that these things are real. There is no space, there is no time, but there is a experience of it. And I guess I'll cut myself off because I probably could just yarn about this stuff forever. I might even be here forever. We might even have been here forever. Based upon the time that we experience. We say, oh, we're only here for a limited amount of time. Well, if time's an illusion, maybe you've been here forever. Maybe you've convinced yourself, maybe we've all convinced ourselves that we are only here temporarily because that's the most enjoyable thing for us to do. If we actually realized that we were here forever, well, we wouldn't be here. But anyway, I'm going to cut myself off. But I just want you to become aware that you don't actually know what space is, distance, and what time is. You don't know what these things are, yet for some weird reason, they're undeniably real for you. I just want you to notice that. Anyway, that's it. Again, I will be deepening these talks. At the moment, I'm just interested in making people become aware of what I'm saying, just aware of it. But I'm going to be deepening them a lot. And I have so many ideas here that I wish to present in an understandable way to people, in terms of philosophical systems, in terms of educating each other, in terms of understanding, in terms of a lot of things, even in terms of physics and thought. I have so many concepts which I've been hashing out for years, and I am interested in presenting that through a new form here. Not just like a paper in university, but rather through some sort of public form like YouTube. But anyway, that's it. I hope your studies are well. I hope your exams are going well. And I hope you can become aware of how strange existence is and how beautiful and profound it is also. But that's it from me, and I'll see you when I next see you. Goodbye.